Okay, guys, I just wanted to do a quick overview in chapter 5.3 and 5.4. There's some confusion, and it is a tricky section of the whole chapter. So I'm going to do a video explaining 5.3 and 5.4 and going over the answers for your homework for 5.4. So we're talking about polynomial functions. They're also called power functions. The domain is all real numbers, so we like this. So you can put any number you want into this function, and you'll get an output. So here's just general sketches of the graph. So when you have an odd function, to the third, to the fifth, your leading term, one arm's going to go up, one arm's going to go down. Now, I kind of say it looks like the Loch Ness Monster. If you're to the 7th, to the 11th, whatever. If you're negative, you're going to flip-flop. Okay? We don't really say positive or negative. We say when you're greater than 0 or less than 0. So I just want you to get used to that when you get to your higher math courses. If you're even, you have that parabola shape. If you graph this in your graphing calculator and it's not this shape, that's fine. I'm just more curious about the end behavior. So if you're negative, you're less than 0, then you would then flip downward. So you need to kind of have these memorized, like your times tables, so that as you go into pre-calc, etc., you'll look at these functions and in your mind's eye, know what your graph is going to look like without having to graph it at all. Okay? So we use graphing calculators to check our work, but we don't use them first thing. We should just go to what we know. All right, so knowing that, you go to the next page in your notes. I have these all filled out for you and attached. So I'm just going to go to the parts where I think there's confusion. So this is determine the end behavior of the graph. Well, this is an even one, so it's going to look like a parabola, but it's negative, so it's going to flip down. Okay, the end behavior. Where are the ends going? The ends are going to negative infinity. Okay. The outputs are going to negative infinity. Both of them. Our outputs, are they our x or our y? Well, output would be your y values. We also say our y values are also called f of x. So both of our f of x's are going to negative infinity. We have x to the 5th. Well, it's going to look like the Loch Ness Monster. So one f of x is going to positive infinity and one output, or f of x, is going to negative infinity. Here, one f of x is going to negative infinity and the other is going to positive. So they want you to determine the end behavior. Well, here, both outputs are negative infinity, but here one output is negative infinity and the other is positive infinity. So which one is it? Well, it depends as you go along your graph. So if you were to have a better looking graph, let's say, if I were to graph the one function like this, as x gets bigger, your graph, your output is getting bigger. So you would write that as x approaches positive infinity, what did your f of x do? Well, our f of x went to positive infinity as well. And you'd say as x approaches negative infinity, so you're saying as x gets bigger this way, and as x gets bigger this way, -1, -10, -3,000, that's approaching negative infinity. F of x would then be approaching what? It would be also approaching negative infinity. So that's how you'd write your answer. So you're always going to write as x approaches infinity, as x approaches negative infinity, but these two will be the ones that change depending on your scenario. So here, it doesn't matter. They're both going to negative infinity. So as x gets bigger, f of x goes to negative infinity. And as x approaches infinity, f of x also, negative infinity as well. And as we just did this one up here, As x gets bigger, so does your graph. As x gets smaller, so does your graph. In this one, it's the opposite. So as x gets bigger, your graph is getting negative. And as x gets negative, your graph is actually getting bigger. Okay. Now, turn the page for a second. Throughout your notes, I know I have these little quick quizzes or checking for understanding. So in part number 2, it says describe the end behavior. So I want you to pause the video and I want you to try it yourself. And imagine this is the part in class where I say, okay guys, try this on your own. Raise your hand when you're done for a sticker. And then I go around and I'm like, yeah, Curtis, good job, sticker. Help and check somebody. This is what we'd be doing right now. I miss you guys. I miss class. So let's just pretend that's happening right now. So this one would be like a parabola shape. And they'd both be going to infinity. Remember, pause the video and try it yourself first. Okay? Whoa, focus. Okay. And this one, it would be like the Loch Ness Monster, but it's negative, so it'd flip-flop the other way. Okay, so as x approaches infinity, as x approaches negative infinity, what's happening? So as x gets bigger, your y gets bigger. And as x approaches negative infinity, your output, your y or f of x, is going to positive. So this is your answer. This is describing the end behavior. And this one, as x approaches negative infinity, positive infinity. As x approaches positive infinity, f of x is going negative. And as x approaches negative infinity, f of x approaches positive infinity. Okay. All right, now go backwards in your notes to this page. Okay, we're going back to where we were. So now that we're talking about the end behavior, we're talking about turning points where our graph changes, high to low, low to high. So I started writing turning point, really it should be down here. And you guys should have that in the notes that you copied. There's a whole PDF file with it filled in. So it says when a function rises then falls, that's a maximum. It's a local max because it's not necessarily the overall maximum of the whole graph, but when you rise and fall, that's a maximum. You can have more than one, you can have two, you can have one, you can have none. It says when the function falls and then rises, it's a minimum. And these are called turning points. Now, it depends on what textbook you have. Some call them local maximas or relative maximas or maximums. It just depends on the textbook you have. I say this all the time. Okay. I don't know why I drew it like that. Okay. If you were to graph this in your graphing calculator, now you all should have one because I assigned you one. You're welcome. Okay. Let's graph this. I don't know why this is in here. This is one that one of you guys returned to me. And this is what it was. Okay. Let's see. Let's put this in our graphing calculator. So negative, and make sure you use negative, not minus, 2x to the third minus x squared plus 5x plus 6, and you hit graph. If you're like, Miss Katsura, my window's messed up, remember you can always go to Zoom and go to Zoom standard for a standard viewing window. Enter. Okay. Well, I don't need all this junk down here. So I need y values that don't have negatives. So just to get a better viewing window. So I'm going to go to window. I don't need negative values for y. So let's start with not that, but let's start with 0. Hit graph again. it's a better view, but I only need from like here to here for my x's. So we can get rid of these, get rid of these. So instead of like -10 to 10, let's do like -5 to 5. That's prettier. Okay, and I stretched it out. So I need a local min and I need a local max. So let's go to second trace. We did this with quadratics. Enter, I want a minimum. Now, if you put a minimum where there's a maximum, you're gonna get errors. I need left bound, so go to the left. Okay, press enter. Now go to the right. See, look, it's creating bounds. So if you go to the right, it's telling your calculator, between these two values, enter. Between these two values, guess where my minimum is. So they want you to say, hey, guess where it is so we can accurately use these numbers to come up with it. Enter. Oh, my minimum's at -1.09, comma 1.95. I don't need the 1.95, and I'll tell you why in a minute. I'm just curious about the x value. Now I need my maximum, so I'm going to second trace. Whoops, second trace, maximum. So go to the left. Okay, enter. And we're going to go to the right. Enter. What did I just do? Okay, do this again. Second trace, max. I'm trying to look at my iPhone and look at the calculator at the same time. Left. I don't know why I had to say iPhone. Okay, let's see. Enter. Sure, 0.76. Okay. So now this section, they want the intervals, like from what to what are you decreasing, from what to what are you increasing, from what to what are you decreasing. So I say it's like a roller coaster as you go left to right. So I know this arrow's up, but imagine you're at the top of the hill and you're going down, and then you're going up, and then you're going down. Now there's 3 intervals here, and there's 2 points. Say I had 4 points, there'd be 5 intervals, okay? So decreasing. We are decreasing. Decreasing is your y value. So we want to know the x value. So from what x value to what are we decreasing? Well, we're at -1 here. -2, -3, -4, -5. So you start from way up here. You're saying from the negatives, you're starting up here and going down. Well, the arrow's continuing, so where did we start from? -10, -300. We started from -infinity, and we stopped decreasing until -1.09. And then from 1.09 to 7.5, or 0.75 or 0.76, I should say, we increased. Now I have brackets on numbers we actually touch. You don't actually touch infinity. You're approaching it, but you never touch it. You never reach it. And then from 0.76 onward, or we use this U as union, like and, like the letter Y in Spanish. Union this interval and this interval. We are decreasing. Okay, it's a little tricky, I know. We're going to do this again with your homework assignment. That was chapter 5.4. It's a 4-graph worksheet. So my advice to you is stop the video, graph these in your graphing calculator, and graph them at their maxes and mins. Like, I'll get it out in a second. And then I'm going to make another video with the answers.